Greetings and welcome to the introduction to astronomy. In this week's special topic in astronomy, we are going to talk about gravitational waves and try to understand them a little bit better. So first of all, what are gravitational waves? Well, gravitational waves are something that was predicted by Einstein here, and they were predicted as part of the theory of general relativity. And they will occur when any object with mass moves. So if an object has mass and it moves, it emits gravitational waves. Just as electromagnetic waves, light is caused by charged particles moving. Then we can also see here gravitational wave is caused by mass moving. Now that means you moving around will emit gravitational waves. So how do we go about detecting these? Well, gravitational waves are extremely weak. And that's because the gravitational force is extremely weak. And it is the weakest of the four forces of nature by far. It is only strong because it acts over very large distances, which some of the forces do not. And the other force, the electromagnetic force, things tend to be neutral in charge, and therefore we don't detect a lot of that on larger scales. But the gravitational force is weak, and therefore the detection is weak. But we would see something as we'd have, say, a moving massive object. We might see something like this, where it is emitting gravitational waves as two objects move around one another, and they would give off a series of gravitational waves. Now, if you want to detect this, you need extremely sensitive instruments. And that's why it took us a long time to be able to do this. In fact, those sensitive instruments, one of the prominent ones that was used was called LIGO, the Laser Interferometer Gravity Wave Observatory. Now that is set up something as I show in this next image. So let's take a look at that. And what it has is a laser that goes out and then splits the light. So the laser goes out here, the beam splits, and it sends things in one direction and in two different perpendicular directions off to a test mass off in the distance, which could be kilometers away down long tunnels. They then come back and can be sent down to a detector here, looking for differences between the ones going in one direction and the ones going in another direction. So you're looking for variations that are a fraction of the width of an atom. So that's why these are so hard to detect. And in fact, there are two observatories that are used for LIGO. It is one in Louisiana and one in Washington State in the United States. Now, the first detection of gravity waves was indirect. They were predicted by Einstein back about over 100 years ago. But it was 1974 when the decay of a binary pulsar matched up. So the amount of energy being lost by the pulsar matched the amount of gravitational waves that would be predicted from general relativity. So that wasn't proof, but it certainly put us on the right track that gravitational waves exist. Now, a little while later, in 2015, we got the first detection. And here we see those two detections here in Hanford, Washington, and in Livingston, Louisiana, the two that were observed. And as the two black holes in this case, we saw merging black holes as we got the motions here, the detections, we got this little ringing effect, and then it settled down as they collided. So as the two black holes collided and merged, we got this detection, which confirmed the existence of gravitational waves. Now, why do we need two? Well, remember, we are looking for extremely tiny variations. So any little thing going on in one area could produce a false signal. So say a distant truck rumbling by on the highway might cause an artificial signal that looks promising, but it wouldn't happen at exactly the same instant in both locations, and therefore two or even multiple locations are used. Now we now have over almost 100 detections as of 2025. And it's really opening up a whole new realm of astronomy. Just as we did with radio astronomy when we took on a new type of electromagnetic light starting back in the 1930s, really opened things up. Well, now we're getting a whole new look on the universe. And as we're able to detect fainter and fainter detections looking at less and less massive objects, we will learn even more and get a better understanding of the universe and of the gravitational waves. So let's go ahead and finish up with our summary. And what we've looked at today is gravitational waves formed when any object that has mass moves. So the object moving creates gravitational waves. They were predicted by general relativity, but not detected until about 100 years later, when instruments were finally able to detect these very weak waves. We now are at nearly 100 detections, again opening a brand new era of astronomy. So that concludes this week's special topic in astronomy on gravitational waves. We'll be back again next week for another special topic in astronomy. So until then, have a great day, everyone, and I will see you in class.